In fact, we have three Nobel laureates among us. One died 10 years ago, so I'm going to show you one of his slides. But we do look at issues that are of importance to both scientists and people of faith. And the ASA, as mentioned, the American Scientific Affiliation, we as engineers and scientists commit ourselves to good science and also to maintain our faith in the veracity of Scripture, in a personal God, and we try to bring those things together that they actually complement each other. The topic I selected, really, this may be a little lesson about creation care. Does it matter? Obviously it does. I'm going to only touch upon one area of that, which is of tremendous controversy now in especially in the production of natural gas and the competition between renewable energy technologies. I have been involved from weapons in several laboratories to fusion and nuclear power. Finally, I got converted to renewable energy. So my last 30 years has been preaching the sun and the sun, S-O-N and S-U-N. So that's where I am now, and it's going to be part of what I will be presenting to you. We are accused, Christians are accused of exploiting planet Earth because of the statement in Genesis 1:23. I'll read you from the Tanakh version, the Hebrew version. It says, "Be fertile and increase, fill the earth and master it, and master and rule the fish of the sea, the birds of the sky, and all the living things that creep on earth." And this is interpreted as exploited. It doesn't say that. It says to rule over. And the other proof is Genesis 2:15, the Lord took man and put him in the Garden of Eden to work and take care of it. So it is extremely important for Christians to realize that all we've got is one planet. There may be 10 to the 24 planets, according to statistics, in the universe. But nobody knows if there's anything else like this. All we have is this, so we better take care of it. And that's why I decided to take that subject first. Let me skip this one. Yeah. In other words, humanity has all kinds of problems. And Nobel laureate Richard Smalley came to our laboratory and gave us a talk. And he presented this slide, which I slightly altered it. Smalley became a Christian at the end of his life. He died about 10 years ago. But this is what he showed, and I agree with him. In order of priority, it's energy, water, food, environment, right down the line. Because without energy, there can be no water. Without water, there is no food, and so on. So it is of high importance, energy. But population is, of course, the one that decides or affects a lot of these problems that we have. 7.3 billion now, probably going to 8 to 10 billion. So this is really, these are some of our problems we face, or difficulties. What I will focus on is energy and environment today. And I'll tell you exactly what I'm going to do. This will be my outline. In other words, the issue right now, I don't know if you've been part of it, there's tremendous competition, tremendous issues on natural gas from shale. Because of its environmental problems and so on. And all kinds of legal activities are going on in Colorado. People saying, not in my backyard, we don't want that, and so on. Where there's others saying natural gas is wonderful, we should exploit it as much as we can. And it's become a national problem, and it's competing with renewable technologies. In fact, words going out, there is not enough investment money for both, either natural gas or renewable technologies. We may not be directly aware of what's going on. So I decided to make a presentation. I was invited by the American Association of the Advancement of Science to make a presentation on this issue, which I'm going to do that to you now. And the point is this, 4 points I'm going to do. First, it's fracking that's causing the problem. Okay? hydrofracking is causing problem, and you'll see why. So we'll look at that first quickly. The effect of methane on climate, because fracking is where we're getting our methane from fracking, hydrofracking. And methane can be a very bad, pure methane in the atmosphere is much worse than CO2. We'll see that. Then status of renewable energy technologies, where are we now? And then number 4 is the solution. How about instead of competing natural gas and renewable energy, can we use a win-win situation and a synergy between the two? All right? So that's going to be my point. What is that synergy? So to do that, that's okay. Very, very brief look at what fracking is. This is a very, if you Google it, you find this. It's nothing.
Should I turn off the
So what?
Should I turn off the light?
Is it? I don't know if it's.
Can
Can
everybody
you see
see?
fine? I don't think there's any. Yeah. Fracking is basically horizontal drilling. It started in 1947, but as things developed, it became less and less expensive, and of course oil prices went up. So horizontal drilling and fracking became important. What you do is basically you pump. First you send a shape charges, and you cap at the end. You send shape charges, and then which essentially opens up holes. Then you send high pressure water, which then goes into the formation, which are the shale. This black shale is 100 to 300 meter horizontal layers, 4 to 10 kilometers below the earth. And there's plenty of it. This country is just blessed with shale gas. And so the fractures then forces the natural gas to come bubble through, and then a better one is, the next one is a little more detailed. Vertically then horizontally. What has improved is here we have high density polymeric systems, or PVCs, that do that, or ductile iron. That's why you can actually curve this way. There's a certain angle you have to do it. Again, with high pressure water, these are the fractures that forms, and the gas bubbles up. But the problem is it requires a huge amount of water. Millions of gallons of water has to be set up under pressure. And it also has to have propellant in it, sand, and that propellant, essentially, when the fractures are formed, the sand keeps those fractures open. And so gas and oil bubble out. Then you have to take, and the water, of course, becomes like a brine. It has in it additives which are, you can't use the water, in other words. You have to either go through a cleaning process or re-inject it in wells. So it is that you need 200 trucks for one such, 200 trucks with water, and several with a propellant to do this. So it's a huge, no wonder people say, no, not in my backyard. Imagine 200 trucks rolling down near your house and doing this kind of a thing. But anyway, fracking has become doable. It is economically feasible, at least right now. We're now at $75 a barrel, right? If we go much lower, it's going to be problems. That's what you need to break even. But because it was $100, $105 a barrel, it was very profitable to do that. But it's here, it's going to do it, and I'll show you the importance of it. All right? So let's do this. Let's look at issues regarding fracking, the plus and the minus side. There are no roses without thorns, correct? Nothing is free. Not even renewable technologies is free with troublesome things. So let's keep that in mind. And here it is. NG is the natural gas from shale. A third of U.S. production right now is through fracking. That's a huge amount. This is why it can make us very soon, actually it has made us independent of imports. Contributes to energy independence for the U.S. And it has already. Methane combustion generates 50% less CO2 than coal, so it's a better fuel than coal, right? And we're going to talk about environment briefly. Methane leakage from wells is negligible. There's question mark, I'll come back to that. Methane in air decomposes. If methane just leaks into the air as methane, it lasts 12 years and then it decomposes, whereas CO2 can remain from 50 to 100 years. So in that sense, methane is better than coal. All right? And then finally, it is cheap, $4 per million BTU versus $21 per barrel of oil. And this is why in my country, Armenia, 80% of the cars are now running on natural gas because it is so much cheaper. And it doesn't take much to, you have to have these high pressure tanks in the back. You have to use pressurized system. But it doesn't take much to fiddle with the engine to let the to use natural gas. But what you need is an infrastructure. You need gas stations that give you not gasoline, but natural gas. So this is the promise. Well, how about problems? Fracked wells deplete in 3 to 4 years. They deplete very fast. Once it starts bubbling up, the first year it goes down 60%, within 2 years it's down 80%, which means that every 3-4 years you have to drill another well. This is why now all over the US there are tens of thousands of these wells, tens of thousands going. And that's one of the big issues. Where are these? What are they doing to the environment and so on? The second problem is the amount of water needed. And usually if you go to the desert areas, where are you going to carry this kind of water? Because water is the one that fractures the formations. Flowback wine. What do you do with it? It actually creates mini quakes. I have an article here, if you're interested, in which they did experiments in Texas, in which they actually show that within 50 miles from the hole, depending on the tectonic structure in the ground, you have mini quakes up to 3 to 3.5 in the Richter scale. They're actually micro earthquakes, but then there are the bigger ones. So the question is, you have to be very careful where you drill. Is it going to cause earthquakes? And it's happening. So that's an issue. Methane traps 21 times more radiation than CO2. Actually, it could be even 70, depending on when you're counting. So methane itself is very, very greenhouse gas type. So you have to be very careful not to leak this stuff. Abandoned wells are source of methane leaks. Every time you close a well to start another one, there's a leakage. And this methane gets into the air. 12 years, fine. But in the meantime, it's adding to the budget of greenhouse gases. So let's do this now. We can always, man is very ingenious. You can always find a better solution to do fracking. And this one is called propellant fracturing and stimulation. Richard Pasamanik is a colleague of mine. We worked together to develop a solid rocket propellant instead of water to do fracking. We did it for vertical wells. Then he carried it through and came up with how to do it in horizontal drilling. What you use is a special solid rocket propellant. What you do, I'll show you an example. It's just a chunk that you send down with a trigger wire, wireline. All you need is a wireline track, a propellant, and it is not a detonation, it's deflagration. It burns. The detonation will break up the tube, so you can't do it. So it doesn't require any water or propellant. Immediately a problem is solved, right? Requires, point number 4 is very important. All you need is 3 staff per well and half a day to do the job of 25 staff for hydrofracking for 3 days. And this has a very interesting unintended consequence. Halliburton took this contract and started drilling. We've done about 1,000 of them, and every one of them has worked. Halliburton suddenly says, hey, wait a minute, we're going to lay 25,000 of our employees. We can't do that. So they turned this thing back and they're doing hydrofracking. Europe took it over, and Norway and others are doing it. It has been extended. As I said, 1,000 wells have been drilled, and they're actually Here's a little more of that. It's a radial, it burns radially inward. The length can be 10 feet to 25 feet, depending on how much fracturing you want to do. It doesn't need any gas, it just completely burns, and it's only CO2 left, so there is no toxic gases when you do this. And it's, as I said, 1,000 wells have been done, and not one of them have broken the well casing. Okay? So this is it's an excellent alternate to hydrofracking, and I hope they pick up again in this country. All right. Now, a few words about climate change. And I know some people get very upset. There are two problems. Climate change has two things, scientific and political. It's the political one that tries to kill the scientific activity, unfortunately. This is one of the IPCC, the International Plan for Climate Change, has been doing meetings every couple of years, to how do we deal with greenhouse gases and the climate change as a result of climate changes. And so I have there's about a dozen computer codes or models that try to take a very complex atmosphere and ocean and try to estimate is there really a climate change because of anthropogenic effect due to CO2. This is one of the nicer ones. It's very, very busy. Unfortunately, let me just give you a few points. My laser pointer doesn't show, so I have a stick in my hand. All right. This is the emitting compounds. Okay. Well, this involves both direct gases and indirect gases, and here is the list of them: CO2, water vapor, chlorofluorocarbons, N2O. And we look at methane. 1, 2, 3, 4. Methane keeps showing up as a anthropogenic gas which gets into the atmosphere. This side shows the radiative forcing. In other words, these gases do radiative forcing. They trap the infrared radiation and heat up the surface. It's very clear that it happens. And so this line is a dividing line. Anything to the right is where greenhouse gas effect takes place. This is carbon dioxide. It's the strongest. All right. And on the left side are particle, soot, volcanic eruptions, and so on, clouds which reduce the temperature. So the idea is, what is the net forcing function? The calculation. The important one is this list here. The level of competence. How much do we know what each gas does? All right? And that's where the problem comes. The CO2 is very high. We know exactly what it does. Methane is high. And then as you go down, you find out that when you come to water, it's low. That's the biggest problem, is water vapor in the atmosphere. Because water is only 0.25% by weight of the atmosphere, 0.25. But its effect on climate change is immense. It is either in vapor form or is in particulate form. Particulate would be clouds, snow, rain, and as you know, water is a very simple molecule. H2O, you have oxygen, and then you have two hydrogen bonds. But it is water has very strong rotation and vibrational parts to it. And it loves radiation, infrared. It takes from low infrared to high infrared to low frequency infrared, and either absorbs or reflects. It has a very wide band. This is what makes including water vapor in your calculations difficult. In any case, so that's one of the unknowns. So my point is, climate change is not fraud. Climate change is not a solved problem either. We're working on it. So, if you keep that, I mentioned this because methane is such an important component to this change. Here is what, the lowest level is the solar irradiance. It's a very tiny, over the last 100 years, the sun has had minimum change in its radiation input, it turns out. Even though, if you look at the sun carefully with the NASA results, it's an exploding star. I mean, it's unbelievable what's happening on the surface of the star, on the sun, and you look at it, it's so peaceful out there. But it's 10 billion hydrogen bombs are exploding on the surface of the sun every second. You know, it's amazing what's happening, and somehow the distance protects us. And all we see is its warmth and light. You know, God has a great humor in putting these stars together. All right, so this is the natural effect, and this is the man-made effect. Let me just talk about this and go on. Notice that if we start at 1750, base it at 750 as zero, in terms of watts per meter square, this is what's happening. In 50, this is how many extra watts per meter square is coming on the surface of the Earth. 1980, it is twice that. 2011, it's almost 3 times. But notice these bars. These are the error bars. You know, you can't pinpoint. So you have to do statistical evaluation. But all of that, the trend is always the same. Something is happening, and it looks like it is anthropogenic, or man's effect. Here is, for example, what gases, what goes into the atmosphere. Here is natural gas, this is oil, this is due to coal, okay? And the atmospheric CO2 is going this way. It started with the Industrial Revolution, and it has steadily gone up. So one thing we know for sure, we have added way too much CO2 in the atmosphere. Now, there's something very interesting I'll come back to. In this last 15 years, surface temperature of the Earth has not changed. CO2 has gone up, but the temperature has remained constant. So those who say the whole thing is fraud, they say, see, CO2 has no effect on temperature. Well, guess what, folks? We just found out what's happened. Let's look at these two. This one is, that's actually the global one. The black lines is the ocean surface temperature that's increasing. But what's happening, and it's been just discovered only a few years ago, is that the ocean is absorbing extra heat and heating up. Look at the rise in the energy content. OHC is the ocean heat content in joules. Look how it's going up. The temperature is remaining constant over the 10 years. But in the Atlantic Ocean especially, it's going up. Also in the Southern Ocean. Look what a change is taking. So deep, all the way down to 700 meters, the ocean temperature is going up. So all the extra heat, instead of increasing the temperature of the immediate environment in the atmosphere, is happening in the ocean. Shortly, sometime soon, maybe a decade, this whole thing is going to reverse, and the heat's going to come up. So finally, the answer is this. The reason the temperature hasn't changed for 10 years is because the ocean absorbs this extra heat. And also it absorbs CO2. And if it's too much CO2, the ocean becomes acidic. If it becomes acidic, it destroys the animal life or fishery and so on. Too much acid. There's a balance there that gets shifted if there's too much CO2. All right. Here are some examples of heating of the atmosphere. These are actual measurements. People say, well, how about 4000 BC and so on. Here's the carbon dioxide. Look how fast the change has taken place from the Industrial Revolution. All right? No major cycles. This you can determine from your ice, what do you call it?
Ice cores.
Ice cores, how much CO2 has been in. So definitely this is us, folks. This is us, all right? And look what happens to the Arctic. Oh, this is what it was up to 2000. Here is where we are now. It's melting. So something is happening. And this is why I like to call it climate change is really what's happening, all right? It is both heating up. Let me give you one example. These terrific storms that's taking place in Buffalo area and the dry Southern California, you know what's causing it? The jet stream usually goes from west to east. It's a pretty stable flow most of the time. What's happening now, measurements show that the Arctic temperature is going up. The tropics is remaining the same. The delta is decreasing. So the jet stream goes unstable and it swings. So it causes complete dryness in Southern California and incredible snowfall in the east. So it's a climate change that's taking place because of these temperature differences that are only recent. Now, having given you the bad news, here is the good news. Our beautiful renewable energy. See what it says? Clean, abundant, affordable. That's why I like to preach the sun. And this shows the various technologies, photovoltaics, wind, geothermal, and so on. I'm not going to go into detail.
What's going on with those cloud formations behind windmills?
Oh, these are, it actually shows the wakes. In other words, what you want to do is, these are models. You want to see how you want to put your wind turbines so they won't block each other. And to do that, you know, you blow smoke and find out how you should set them up. Okay, it's an experiment that's being done. Yes. You stagger them so they won't be in each other's wakes. All right, going back, let's go to shade, role of shade in the U.S. and supply. Here is where, this is the billions of cubic feet of each one. This is from the green. Green is the natural gas that's in coal. This is the other type. Coal mines themselves produce methane, but this is the one that fracking is doing, okay? So fracking is adding natural gas, is affecting the atmosphere, and it shows where this is happening. These are the various fracking areas, back in Marcellus and so on. It shows how each of them produces methane, which can they leak into the atmosphere. So that red is the red signal that we have to be careful of. Now, I'm going to come to the synergy. But before I do that, look at the gas prices. One of the problems with natural gas is you cannot, it's variable, it constantly changes. So you can't predict 10 years from now. It can be abundant, the price comes down. It can, like it's happening with oil. You know, 105, all of a sudden we're below, in fact today it was $74.4 per barrel. All right, so keep that in mind as we compare it to renewable technologies. So this is what, I'm sorry, let me go back. Yeah, this just to show you, renewable energy development has been slower than usual. All right, for example, it's only 11.2%. This is 2011, I think, where we measured it. Only 11.2% is renewable energy in the U.S. Everything else is either natural gas, petroleum, and the majority of renewable gas is either biomass, burning wood, or hydro. The solar and wind are still kind of a few percent for this country, not so for Germany. They're much ahead of us. Okay? So U.S. hydropower has remained constant. Wind has really picked up. We're now talking about gigawatts of power. Biomass has kind of remained the same. Solar is just picking up. So we're getting there. Renewable is picking up. The reason I'm saying that is that one of my conclusions would be natural gas should be a bridge to the future while renewable energy finally catches up. Because ultimately, that's the most benign source of energy. All right, and what's happening? There are 5 converging trends that I'm going to mention for renewable energy. I mean, the time for renewable energy is here already. Number 1, the increasing environmental awareness is forcing a lot of countries, even China now, because they're having tremendous problems of polluted air because of coal. Even they're now shifting towards renewable technologies. One of the highest, largest wind farms are in China. All right? Environmental awareness is forcing us to think through what are we going to do for the future. Availability of new technology options. Renewable energy prices have really come down. When I first started at renewable energy technology, at NREL, which was like that time Siri, a peak watt of photovoltaics was $40. Today is $1, especially if it is Chinese. Chinese are actually flooding the market with low-cost photovoltaics. All right, so, and the technology is moving, and as an improvement in every area of renewable energy technology. So, it's one of the converging trends. World energy demand is growing. You should see what's happening in India. They can use all the coal of the world, right, to meet their energy demand. Let me give you a number. You know, we are about 6.5% of the world's population. You know how much energy we use? 26%, 26.5%. Imagine China and India doing that. Where are you going to get the energy? 1.2 billion people, 1.4 billion people. So it's serious. Energy security and uncertainty. In terms of energy security, the best is renewable technologies. You know why? It's dispersed. It's not concentrated. Nuclear power is great, right? You build a 1,000 megawatt nuclear power plant. All you need is an organized terrorist attack with a 747. You blow up a power plant that would not only distribute radioactivity, but turn off power everywhere, right? You can't blow up what do you do with a wind farm where you have wind turbines scattered all over the place? It's distributed, so you can't attack and destroy, causing major problems. In that sense, in the other sense, renewable energy is the only energy that is equally divided all over the world. You don't have to have Saudi Arabia, Yemen, or Iran to produce oil. Everyone has sun, everyone has wind, or biomass, or hydro. So every country has something in renewable technology that they can use. It's evenly distributed. I think it's God's greatest gift to planet Earth. And then, of course, this is the biggest one, business. It's $1 billion business right now, renewable technologies. So investors can jump into it, except natural gas is coming back. So all of a sudden, the same dollar is going to be used either for one or the other. Okay, here is what the energy mix is today in the United States. This is coal coming down, natural gas picking up, nuclear remaining constant. Everyone is afraid, not in my backyard kind of thing. Hydro is decreasing in value. And then the non-hydro renewable energy is starting to pick up. See, this is the lead. This is why I said five of these factors are converging. The new technology, the security concerns, environment, these are all converging, and all of a sudden renewable energy is turning non-linear. And of course it's in the news everywhere. In Colorado, more than a gigawatt is being produced by wind right now. This shows today's capacity. This is renewable energy, this portion. Okay, in 2035, hopefully it's going to be this way, much more. In fact, when I first joined Solar Energy Research Institute in 1978, Carter had given us a goal, 20% renewable energy in year 2000. Well, we're 2014 and it's only 11%. The new goal is 20% in 2020. Let's pray that happens. Okay? Right to you, representatives. I'm going to show this. You see, this is the various sources of energy, but this is it. I mean, the sun in one day can provide more energy than the whole world using it. The problem is it's dispersed. You have to focus it, you have to concentrate it. That's where it comes from. But it's there. All right, now, this is the meat of the talk. Let's compare natural gas and renewable energy and see if we can pull some of these things together. Okay, this side is the risk of natural gas, and this side is the advantage of renewable. Okay? Long-term availability. Eventually, we're going to run out of natural gas. I mean, it's not infinite. Okay? Maybe now it's great time. How about 50 years from now? Pipeline constraints. You have to keep building pipelines. So that's an issue. Fuel price volatility. I just showed you. The price constantly changes, so you can never really plan long term. Then you have to meet certain portfolio standards, environmental standards. And so what are the targets for the future? If they can become stricter and stricter, all of a sudden natural gas is going to become expensive. So that's a question. And then of course the environmental regulations. Now wind, solar and so on have no fuel risk. It's always there. You can plan on it. The sun is there, the wind is there, you know your resources. And then of course renewable energy meets these renewable energy standards for environment. Okay? So that's the bad news and the good news. But let's turn it around now. Now let's show the problem with. Here is the problem with renewable technologies, and here is why natural gas is great. Cost competitiveness. There's continuous cost reduction going on, and it's uneven. We had all kinds of solar photovoltaic developers here in this country. Half of them have gone bankrupt. You know why? China is dumping cheap photovoltaic quality. They're not cheap, but they're low-cost systems and shutting off our systems. All right, so there's competition going on the availability of some of these systems. Federal incentives. All solar systems have federal incentives. If right now you want to put photovoltaics on your roof, I don't know what the deal in New Mexico and California, you can write off 30% of it up front. So in other words, it's an incentive for you to use it because the price of solar is still higher than coal and natural gas right now. We're getting there, but it's higher, so you need incentive. But those incentives can change. Every 3 years, Congress says we're going to stop providing incentives for wind. And of course the wind lobby gets in and says, hey, no, let's renew it. And you know that coal, petroleum, oil is superbly incentivized. We spend billions of dollars with our Navy protecting Middle East so the oil will not stop from coming here. And we'll come to that. That incentives are stable. Resource availability and dispatchability. The problem is, before you use renewable energy, you have to find out, do you have enough sun? Is your home facing south? Is there enough wind for wind turbines? So you have to do resource analysis. That's an important thing to do. And then they have low capacity value because the wind doesn't blow all the time. It's intermittent, right? There's no sun at night. So what do you do? Which means that your utilities don't like wind or photovoltaics because they change constantly. So what you have to do is you have to go into new dispatchable systems. They're called digital system, smart lines, power lines that can respond within seconds instead of 15 or 20 minutes for a change. That way, when the wind changes, utilities can immediately respond and turn up something else. That's a problem with the renewable technologies that has to be solved, and it's working on it. So that's another problem. And then, of course, transmission. Where do you put your turbines? You have to be in wind is usually in places where there are no human beings, right? You try to, who would want to put a house on a mountain or on a pass where the average wind is 40 miles per hour? Stupid, you don't do that. All right? So you put, the wind turbine should be in places where they're away from power lines, which means you have transmission problems. $16,000 per mile. Right? So that's another issue you have to face. On the other hand, natural gas is great. It has the lowest LCOE, has, in many locations, it has, incentives are always constant, they never change the incentives. It's great flexibility, it's constantly flowing, so there's no problem. Utilities always have natural gas. And here is where a joint effort comes in, all right? Why don't we take the strengths of each and put them together? That is my message today, and that's what I'm going to end up with. So let's look at, here is the platform of partnership. A few ideas for dialogue and collaboration. Just to give you a few examples. Hybrid technology opportunities. Now, how many of you have hot water, solar hot water on your roofs? Anybody? There's a lot of sun here, folks. And it's very low cost now. You can recover in 2 years when you put solar hot water. But what do you do at night? Storage is usually not good, especially if there is several days of cloud. So what you do is you tie it to the natural gas backup. So natural gas can be a backup for solar. This way you reduce the cost of your payments to the natural gas by using solar hot water. Hybrid, these big systems, that SEGs that you see in Southern California, the huge megawatt solar collectors, all of them are backed up with natural gas, because at night you have to have natural gas. So here is one partnership that goes together, and it's being done now, and can be done even more so. Which means you can co-optimize your system. You can integrate the two from the very beginning. You don't go only natural gas or only renewable energy, you try to co-optimize. For marketing, instead of fighting in the market, saying, hey, natural gas, yay, frack. Why don't you say, hey, renewable energy and frack? Okay? In other words, prepare the minds of the people that you need both, not one or the other. Some of them are very obvious. Transportation is a very interesting one. You know, right now we use petroleum, okay, gasoline. Some trucks run on natural gas, you've seen them, all right? And as I say, in Armenia, 80% is natural gas. But natural gas has to be compressed. Well, what are the alternatives to oil? Natural gas, hydrogen, and biofuels, right? Bioethanol or diesel, biodiesel. These all can replace oil. And they're benign because their exhaust does not put out a lot of CO2. Hydrogen doesn't at all, it's H2O. You burn hydrogen, water comes out, all right? So, how do you work out the availability of natural gas, the lack of availability of hydrogen now, but the availability of biodiesel? How can you optimize so you can use one or the other, whichever is economically feasible or is cost effective is the word. Let me just skip this. There are several others like this. I'm going to show you instead some. Do research together, portfolio approach. In other words, do you know, when I was at Renewable Energy Technologies, we did very well with renewable technology development, and we never spoke with Gas Research Institute, which is in Chicago, where they did all this design and plan for use of natural gas. Now, believe it or not, they're talking together. They're planning together, they're doing research together, just to make this partnership win-win instead of one against the other. See the point? This becomes part of the creation care that I was talking about. Optimize what we have, make the best of it, and minimize the negatives. And we just go on. Just for fun, I'm going to show you something here. This was published in Science just last week. How far a car can go on a liter of fuel, okay? For 10.76 kilometers per liter, all right? Gasoline can take you to, gasoline is 10,600
Meters.
for that distance. Liquefied gas is 30% less. Compressed natural gas is only 1/3. Unpressurized natural gas takes you only 15 meters. Let me show you a picture which I found, and it's in Sudan, in China. It's so funny. Look at that. This is natural gas, uncompressed natural gas running the bus. Is that kind of cute? Obviously, it's not going to work. You've got to use natural gas intelligently to redesign your. You can redesign your gas tank with some special porous elements and store natural gas. Otherwise, you have to use big, high pressure natural gas tanks. So, in other words, what I was trying to say is, quite simply, the sums of money at stake in terms of investment in energy over the coming decades are staggering. We're talking $1 trillion investment. And that's why win-win situation is important. This is a real pie in the sky. This is our wish. 9.7 trillion of global investment in power generation. To make if you make one of it 71% renewable energy, you have to go into that kind of investment. All this is references. Incidentally, these slides you're welcome to use. I can any one of that you want. The whole thing I leave with you. There is nothing proprietary here. Here is just a list of methane leakage. Let me offer you a couple of measurements are being made all over the world because more methane is showing up in the atmosphere than we can measure. Where is it coming from? It's primarily when you process oil and natural gas. That's one. Leakage of pipelines is another one. But it turns out the problem is official inventories of methane leakage consistently underestimate actual leakage. This is our problem. All right. So, we have to. This is an analysis done. It's in the February issue of Science. A very thorough analysis done this year to see where is this methane coming from. Remember, it's up 12 times more absorber of greenhouse gas than CO2. So you have to be very careful and not to. If you have a lot of cows, they fart and this methane comes out. That's an important element. contributes to the greenhouse gas. All right. In our case, it's H2S, but for cows, it's methane. Just to end up, that we have, in other words, we can't wait. We've got to do something and do it quickly. There was another one I was going to show you. Let me see. Oh, beautiful. Okay. Let me first talk about this, and 2 more slides and I'll stop. These are called energy substitution models. These are Marchetti curves. What they do is, the question is, if I want to introduce a new fuel right now and get it into the market, how long will it take? Okay? This is the question. And here is what was done by Marchetti. He took everything he could. Wood, the green is wood, coal, oil, natural gas, nuclear, solar. Every one of them follows a very similar path. For example, tremendous amount of research was done in nuclear energy. It increased very much. The market forced it on this line. Solar did the same thing. In other words, if you look here, this is the penetration rate, and this is the year. For a new fuel to penetrate the market, 20% takes 50 years. Not because of technology, because of infrastructure, institution, politics. Anything that you, even if you just invented right now an incredible fuel that you can use, it will take 50 years to penetrate 20% of the market. So we've got a very natural obstacle we have to deal with. Ultimately, finally, the most important thing to do is to use a life cycle assessment. In other words, if you want to design, suppose you want to analyze natural gas versus renewable and so on, you have to start from cradle to grave and see how much money and effort does it take to do it. It's called life cycle analysis. Before you pick one or the other, you have to do this analysis because it takes all kinds of factors have to be put in. Let me show you the last slide I have is here. See, this was developed at NREL, what life cycle does. What are your inputs? Non-renewable materials, obviously. Every renewable energy, every energy is going to require materials, and they are non-renewable, many of them. And then non-renewable energy, you have to use coal or something to get started. You put that in, and you go through a whole process, and out comes net emissions. How does that affect the environment? What is the final product, and how I can use it? This is then a model which you have to use before you pick this or that energy system or combinations, right? That's what you have to do before you do your final decision as to where you want to go. Okay, so that's it. The bottom line is, I've talked long enough. We have two wonderful sources, natural gas. I love it because I get royalties. See, because of my involvement in fracking, I've gotten some royalties, which is nice. I'm biased. But also I'm preaching the sun for 30 years, renewable technologies. So I think we have two wonderful resources in this country. And it is time we use them together as a win-win, to get a win-win situation for all of us. And I believe eventually natural gas is going to be only a bridge to what solar or renewable technologies are going to take over in the future. And that is our dream, that's what's going to happen. And if you realize, you go in the book of Revelation, you find out that there is no need of any of this because God and the Son are the light, the energy of the whole new world system. Maybe that's where we're ending that little bit by bit. Okay, well, thank you. You've been a very kind
Time for just a few questions for our speaker, and then we'll take a break, about 10 minutes or so, for refreshments afterwards. We'll, for those who'd like to stay and have a little group discussion for half an hour, 45 minutes, we'll pull some of the chairs in the circle.
I have some of the references if you want to look at there. You have to.
So does anybody have any questions for Dr.
I look up in the sky and I see the jet trails going overhead there, 35,000 feet, which there are no clouds up there.
Yeah.
And so they're dumping all that water vapor
Right.
up there high. So what fraction of the global warming is it contributed by these jet contrails?
It's hard to tell. It can be significant. Sometimes there are no contrails, because the dew point is such that you don't see any contrails.
It's all vapor.
But yeah, when it's very dry, it evaporates and you can see that. I don't know the answer, but water remains very elusive because of its so many forms that it shows up. Yeah, that's why you are always going to have those error bars. Yeah, good question.
Yeah, with regard to the natural gas, we were comparing liquid and compressed.
Right.
Well, with the liquid, you need cryogenics to store it. With compressed, there's a lot of PV work involved. What about methane hydrate?
Well, that's an alternate, sure. Well, you can do it and then break it up, that's right.
Yeah.
Well, yeah, that's another solution. Good point. Yeah, methane hydrate.
So is that better or more?
I don't know, I haven't done any. Again, you have to do an LCA, to see how much of that you need, how does it break up, and so on. Right. Good point. These are not the only solutions, yes.
The water that's used in fracturing,
Yeah.
can it only be used once?
Yes, because it does the fracturing, it has already it becomes very salty, all right, and well, you can't send your explosives to, once meaning you put it in there,
Yeah,
it runs for 3-4 years, and then you pull it out,
yeah.
okay? So it is, but it's used once because it becomes brine, and it's not suitable for,
Why does the brine make it unsuitable?
well,
Why
because
can't you just re-inject it?
there's erosion, I mean, erosion,
Corrosion.
corrosion sets in,
Okay.
you know, and then there's also other gels in there that are not, supposedly not good for the piping system, so you have to clean it out. Usually, you use that water, you pump it in there, use it for a while, and then you take it out and dump it.
And re-inject it in something?
Inject it in some other hole, or clean it, and the cleaning is expensive, yeah. But it's a huge quantity that you're using.
I understand that fracking comes with earthquake risks.
Right.
Is there a way to mitigate that, or to figure out where would be better places to fracture
Sure.
that might cause less?
Yeah, the problem is we don't know where the fault lines are.
Right.
You know, if we knew, that'd be easy. I have a whole article on that. They did the test in Texas, and it shows it up all the way to 50 miles.
Yeah, so there, and
Many
in Oklahoma
earthquakes show
too.
up. Oklahoma the same way, yeah. There's clearly a one-to-one correlation between dumping fluid
Yeah,
and then generating earthquakes. They're not major, but they could trigger major earthquakes from the mini earthquakes, yeah. So that's something to think about. Where you do it, where you select your well, yeah. Sure.
Tell us again, how is it that you can use an explosive technique for fracturing that doesn't destroy the casing?
No, it burns, it does not detonate.
Oh,
Okay, it's deflagration, you call it. In other words, it's a fast burning, which creates very high pressure CO2. And you've already used an explosive system to get your holes up. Goes right through the holes, fractures the formation. In fact, it does a better fracture than water does. And then it just burns, becomes natural gas, becomes just gas.
so it's really high pressure gas then?
Yeah, high pressure CO2. Just like any of these exhaust fuel propellants, they eventually burn out and produce CO2 and maybe nitrogen. Yeah. And it's a really good thing. I mean, you really save on water and number of people required to do the job.
You mentioned that Arcadine 489.
Yeah.
Yeah, what's the chemical composition of it?
And it's used in short-range missiles, solid fuel. It's the same thing.
Yeah, it could be a nitroglycerin, nitrocellulose.
Something. I have the formula. If you really want, I can get
Ammonium
it.
perchlorate.
No, it's I don't think it has chlorine in it. It's cleaner than that. Yeah. They have to do it because of the use of rockets for space. It doesn't leave bad gases behind, is the problem, is the advantage.
So has this increase in CO2 in the atmosphere also led to increase in plant growth?
Well, I don't know. I mean, plants use CO2, but there's too much of something good. You know, they have too much CO2, the waters become acidic, and that kills life. All right. Nature has a balance that is for ages has held. All right. Now we're dumping 2, 3, 4 factors more of CO2, and not only that, we're cutting up trees. Look what's happening in Brazil. You know, entire jungles are being cut off.
Rainforest.
Yeah, deforestation.
Rainforest.
Yeah, deforestation is going on. Reforestation takes time, all right? Deforestation is quick. Reforestation is years, depending on the kind of plant you put up. But you're right. A lot of people use that argument. They say CO2 is good for plants. Well, is that good for you? Why do we exhale CO2? You get poisoned if you don't exhale CO2. For humans, it's not good. For plants, it's good. But that's a factor that is taken into some of these calculations. The only thing that big table didn't show is gigantic volcanic explosions, because those are single events, and of course they cover the whole Earth with soot, and the temperatures go down. But those are singular events. It's not like Chinese torture, drip, drip, drip. You know? Yeah. Okay. One more.
To what we attribute the fact that the oceans are warming up? What caused that
The
mechanism?
CO2, in other words, the CO2 holds the heat, the infrared, you know, it stays in the atmosphere, and the ocean absorbs that, and it heats up. Yeah. It came as a surprise that it goes down way deep. That's the biggest surprise, 700 meters.
The problem is, if you reduce the CO, the heat will start to come back out.
What?
If you reduce the CO in the
Oh.
atmosphere, then the heat from the ocean will come back out, so it will take a while to.
The ocean has a way of equalizing itself, but it's the only point that I'm raising is that the constant temperature that we see, in spite of the CO2 increase, is because the ocean just stores that heat, and it's increasing. So sometimes it's going to even turn over, you know. Yeah. Can affect this whole business of Nino thing, you know, can be seriously affected as a result of that. So it's climate change is the problem, more than the heating is what I find. Okay, well, thank you.
Thank you.